Question number 3. With the aid of a labeled diagram, explain why magnesium metal is malleable. This is the same as the first question in this test, which is, again, labeled diagram of magnesium metal. We're going with our metal metallic lattice, which is a whole bunch of cations, and then our delocalized electrons randomly sitting in there as a sea of delocalized electrons. This is a cation. That is a delocalized electron. And why are they malleable? Malleable is because the cations are free to move, but still held in place by the delocalized electrons. Again, our go-to sentence as to why metals are malleable. With the aid of a labeled diagram, explains why calcium is a stronger metal than potassium. All right, so these both are metals. So you got one here and one here. Now, again, let's have a look at this. What's going to be the difference between these two? They're all going to be positive. All right, so why would one be stronger? Strength comes from a force. Where does this force come from? Between positive and negative. What is the positive force? If we've got calcium here, what should the charge on calcium be? The charge on calcium should be 2 positive. So each of these here should be 2 positive. Whereas potassium is a 1 positive ion when it becomes, when it becomes stable. So therefore, we have an idea that the 2 ions are different charges. Ca2 plus has a stronger electrostatic force, therefore would be a stronger material. All right, and that is going back to, in terms of answering this question, where do we come from? Let's read through the question and see the fact that we need to define between calcium and potassium, and we need to look for where their strength comes from. Where could their strength come from? A force holding it together. Where does that force come from? The difference between our charged cation and our negative electron. All right, so that's our force here. And I need to work out why would that be different. What is the charge on calcium? It's 2 positive. What is the charge on potassium? It's 1 positive. So therefore, you'd expect calcium to have that stronger force holding it together. Hopefully that makes sense. It's a bit of a random question there, but again, go back to what causes the property. The property is caused by the force, and so on and so forth. That's question 3 done.